Okay, so take two on lesson 8.2. It is on special right triangles. So today we're focusing on two different types of right triangles. We're focusing on 45, 45, 90-degree triangles. So the whole first page is on 45, 45, 90. When I say that, it means that like all of the angles, I just listed the angles for you. The angles are 45 and 45 and 90. And there's something special about this triangle, how the sides all relate to each other. Before I tell you the other type, I'm just going to remind us that 45, 45 means that I've got two angles that are the same. So 45 and 45 are both the same angle measurement, which means my base angles are congruent, which means that my legs are congruent. So it's an isosceles right triangle because the two angles that are the base angles are congruent, and that makes my legs also congruent. And I'm going to write leg next to that and then point an arrow there too. So if I'm talking about the sides that are not across from the 90-degree angle, just the normal sides, I'm going to call them legs. And then the side across from the 90-degree, reminder, we call that the hypotenuse. So it's already kind of a special triangle, but there's something like more special ways we can generalize about every single 45, 45, 90-degree triangle momentarily. Okay, so I just previewed that. I'm going to preview the other triangle and then we'll do the work for each. The other triangle I have is this 30, 60, 90 triangle, and it comes from an equilateral triangle. So equilateral means all my angles are the same. So like angle A is 60, angle C is 60, and then B, if you put those two angles together, that would also be 60. We start with an equilateral triangle and then we drop an altitude. So that means it's perpendicular to the other side. It's also a perpendicular bisector because A and D and C are the same. And then it splits, it's an angle bisector too because it splits angle B equally into 30 and 30. And so that's how I have just this triangle right here on the right. That is a 30, 60, 90 triangle. And there are going to be special things about all of those sides as well. So we're essentially taking two triangles that are already special and then learning more about them and kind of generalizing certain things. Okay, so that's kind of all we're doing today, 45, 45, 90, 30, 60, 90. However, we've never done this before, so we're going to start kind of slow. And we're going to start by using something that I know that we know and have done before, which is Pythagorean theorem. The first thing is it says is how is the hypotenuse related to the legs? Let's look at a couple examples. So suppose each leg has a length of 1. Okay, so I'm looking at this triangle and we're going to pretend like each leg is 1 unit. Well, if each of these are 1, I want to know what's my hypotenuse length. So I'm going to use Pythagorean theorem to find what that h is. Okay, so one side is 1, one side is 1, one side is h. 1 squared is 1, 1 squared is also 1, h squared is still h squared. I can do 1 plus 1, which is 2. And then I need to figure out what h is, square root both sides. H equals root or radical 2. Okay. So if my two legs are at just 1, then my hypotenuse would be a length of radical 2. Okay, that sounds cool. Let's do another one and see if we can like find a pattern here, see if we can repeat any patterns. Now I'm going to try it where my leg is a length of 3. It could literally be any number. I just picked 3 and I just picked 1. I could have picked 20. I could have picked 7. It doesn't really matter. But I think this is enough information to help us find a hint. So I've got 3 and 3 are my legs, and then we have to find h. So again, it's a right triangle, so I'm allowed to use Pythagorean theorem, a squared plus b squared equals c squared to find my missing side. So I'm going to do that. This time it's 3 though as my legs. 3 squared plus 3 squared equals h squared. 3 squared is 9. 9 plus 9 is 18. And then square root both sides. Ooh, 18 is not a perfect square, and there's some factors. So I don't think the answer is just root 18. So let's actually do a factor tree off to the side. Root 18. That breaks apart to be 2 and 9. Oh, and then 9 becomes 3 and 3. Awesome. 3 and 3 is the pair, so the 3 comes out. The 2 has no friends, so it stays under the radical. So my hypotenuse here is 3 root 2. I made you do a couple problems like this on your homework last night too. So you might be like, oh, I see we've done a lot of these things that we get root 2 in our answer. And that's the trend that I want to see. So if we look at the sets that we had 1, we had root 2. I also had 3, 3, and then 3 root 2. In both cases, I had the legs be the same. I had 1 and 1 and 3 and 3. And then the hypotenuse was essentially the leg times root 2. I know that there's no 1 in front of this root 2, but it's assumed. It's like if you have x, there's a 1 there that we just don't write because it's redundant. But radical 2 is the same thing as 1 root 2. So it again has the leg length and then times root 2. So what I'm going to say is for every single 45, 45, 90 triangle, the 2 legs are congruent and the hypotenuse is equal to root 2 times the leg. And that works in all of them. So if I were to generalize, we don't know what our legs would be. So we're just going to call it X. We'd say, okay, the leg is length X, the other leg is length X, and the hypotenuse is length X root 2. If you're like, that makes no sense to me, and that's why you don't like this extended ratio, that's okay. What I need you to know then is that hypotenuse equals root 2 times the leg. Hypotenuse is root 2 times the leg. I've taught this differently in the years that I've taught this concept to a bunch of different students. So if something doesn't work for you, just ask me and I can see if I can explain it another way. So I'm going to now look at a picture because sometimes I think we're visual learners and it might help to put it on a picture. Remember the legs are congruent. So I'm going to label the legs X and X, and I'm going to label the hypotenuse X root 2. Sometimes we see this and you're like, oh yeah, okay, I understand that to go from the legs, you need a root 2, to come back, you get rid of the root 2, whatever. Sometimes though, we don't understand like how it works or mathematically, how can we add in the root 2 or how can we get rid of the root 2? So I'm going to think about like going from one direction and then back and think about what mathematically we're doing there. So if I'm starting at the leg and I'm moving to the hypotenuse, I have to get bigger. The hypotenuse is the biggest side of the triangle, right? We've said that before. I asked what the biggest side was on Monday when we were finding Pythagorean theorem, and you guys all knew it was the side across from the right angle. So I know that the hypotenuse is the biggest side. So if I'm going from the smaller side of just a leg to a bigger side of the hypotenuse, I'm going to multiply by my root 2. So you have to multiply to go from the small to the big. So in order to get to a bigger side, you're going to multiply. I use green because I think of like growing, getting bigger, whatever. It's a weird way my brain works. Now I think for getting smaller, I think blue. Again, can't explain color theorem in my head, but I'm thinking blue. So I'm going to use blue to represent every time we're getting smaller. So if I was to go backwards, and it can go to this leg or it can go to this leg, it doesn't matter. But if you're going from a hypotenuse to either of the legs, because the legs are the same, we are not going to multiply to get smaller. We're going to do the opposite, which is divide. I'm going to divide by root 2. And that helps it get smaller. To go from the leg to the hypotenuse, we get bigger. Leg to hypotenuse is bigger. Hypotenuse to leg is to get smaller. So we divide. Any questions with what I've said so far? Okay, I'm going to do one more example or one more little question, then we're going to do some examples using this. So this question says, why is every 45, 45, 90 degree triangle similar to every other 45, 45, 90 degree triangle? Well, remember back to chapter 7 with similarity. We know triangles are similar by either side, 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 angle, or angle, angle. In this case, it's by angle, angle. They both have 45 and they both have 45. The only other angle has to be 90. So similar means all the angles are congruent and all the sides are proportional. So all the sides are proportional. And the proportion or the extended ratio is this. So that's why all of these triangles are similar. It's by AA. All right, any questions so far? All right. Now we're going to move on to 3 examples, it looks like, and we're going to solve for X and Y. And this is what your homework looks like. And this is what you'll see on a quiz is just triangles. And I'm going to say, find the missing side lengths. We're using our knowledge of either multiplying or dividing by root 2 in order to find the missing length. Root 2 is the only number that matters here. On the backside, that's not true. But right now on 45, 45, 90, it's the side length and then multiply or divide by root 2 in order to find the other sides. So I'm looking at this first one. I have the hypotenuse here. I know I have the hypotenuse because it's across from the 90-degree angle. So the hypotenuse is the biggest side. So to get the legs, I have to go smaller. And since I have to go smaller, that means we're dividing by root 2. And again, it's the same on both of these legs because the legs are congruent in a 45, 45, 90. So to get X and to get Y, I'm going to do 9 root 2 divided by root 2. Oh, root 2 divided by root 2, it's the same. It can cross out. So I'm left with 9. So sides X and Y are just 9. Okay, anybody any questions so far? We're going to do a couple more. So if you're like, I'm like really not sure what's happening, just kind of stick around for a second. Let's see if I can kind of fill some of the gaps in. This next one, I've got 8 is the side that's given to me. And 8 is not the hypotenuse. It's just a leg because it's across from a 45 degree. It's not across from the 90, so that means it's just a normal leg. Well, I know in 45, 45, 90-degree triangles, the legs are congruent. So that means that Y is also 8. There's no math needed. I know X that both the legs are congruent. So 8 is a leg and then Y is the other leg. So Y has to be 8 too. Now I have the legs and I want to go to the hypotenuse, which is bigger. So in order to go to the bigger side, I have to multiply by root 2. So I'm going to do 8 times root 2. Oh, well, that's just 8 root 2. That's all that is. And those are my answers, 8 and 8 root 2. Any questions so far? Okay. I'm going to scroll over so you can still see that one, but we're going to look at the last one. This one, I gave us 4 root 6 and it's just a leg. It's not the hypotenuse again because it's not across from the 90. X is the hypotenuse. So 4 root 6 is a leg. So first, before I do any math, I'm going to label the other leg as 4 root 6. So Y is congruent because it's a leg and it's 4 root 6. Now to get X, I have to do a little bit of math because I'm going from the leg to the hypotenuse. So I'm going to get bigger. So when you get bigger, we multiply by root 2. So I have to do 4 root 6 times root 2. When you are multiplying radicals, and I'll say this later on, but like, and I say this in pre-cal all the time, not as much in geometry, but like so much of our math career is just based on your algebra knowledge. And so like if your algebra foundation is weak, then that makes kind of everything else build on this like shaky foundation. This is an algebra skill now. Multiplying these two things together is algebra. Like we've learned that, or you have learned that, or you'll learn it again in algebra 2. The geometry step was knowing that we multiply it by root 2. The algebra step is simplifying. So algebraically, you can multiply two things under a radical. So I can do root 6 times root 2, and that's going to give me root 12. Ooh, but I also know root 12 is not a simplified radical. So I'm going to do root 12 off to the side. That becomes 2 and 6 is 2 and 3. Okay, we've done a lot of factor trees, so I'm going to not go that slowly through that. The 2 is the common number, so it comes out. The 3 has no friend, so it stays under the radical. So instead of root 12, I'm going to say 4 times 2 root 3. Root 12 simplified to be 2 root 3, but I didn't get rid of the 4. It's still there. Now, just like we could only multiply things under the radical together, we can only multiply things that are not under the radical together. So 4 times 2 root 3 is going to be 8 root 3. Oh, and that's as simple as that one gets. I'll leave that there for a question. Any questions, any thoughts? Any thoughts? Okay. I got one more thing on this page before we keep moving on. This one says rationalizing the denominator. So I have to rationalize the denominator, which is again a skill we've talked about, but not something that I've like explicitly done in your notes. So I've got 12 over root 2. So in order to get rid of the denominator of root 2, I got to multiply it on top and bottom. So I'm going to write a little note to myself if I'm like, oh, I don't remember rationalizing before. Multiply. Let me rephrase it. In order to rationalize, you have to multiply top and bottom by your radical. In this case, it's radical 2, but it's not always. So it's whatever the radical in the denominator is, multiply that on top and bottom, that cancels it out. So 12 times root 2 is 12 root 2. Root 2 times root 2 is just 2. Oh, but I'm not done because 12 and 2 have a common factor of 2. So that's like 6 root 2 over 1, which can just be 6 root 2. Okay. Let's do one more problem like this. So I've got one problem that I have to use a rationalizing denominator. This is our last 45, 45, 90, and then we got to do some 30, 60, 90s. So this time I gave us the hypotenuse. And so in order to go from the hypotenuse to a leg, I need to get smaller. So I'm going to divide by root 2. I have it written twice. You're only going to do it once because X and Y are the same number. They're congruent. So 10 divided by root 2. This is a lot like the problem we just did. Times root 2 times root 2. I get 10 root 2 over 2. Okay, 10 and 2 cancel, so I get 5 root 2. X equals 5 root 2, Y equals 5 root 2. All right. That is the first page. That's all practice on 45, 45, 90. Again, the two legs are congruent and the hypotenuse is the leg length times root 2. And we've done a few practice problems like that. We're about to move on to the new one, which is 30, 60, 90. Does anyone have any questions before we go there? Nope. Okay. Okay, let's move over then. So 30, 60, 90, again, was the one that I told you came from an equilateral triangle. So I just previewed it a minute ago. It's special because it comes from an equilateral triangle. And we wanted to also have side lengths of 2. That's just going to help with our generalizing as we go. So my side lengths are 2. So BC is 2, AB is 2, and then AC is also 2. I did also tell you that BD is a really special segment because it's an altitude, because it comes from the vertex and makes a 90-degree angle. It's also a perpendicular bisector because it's perpendicular and it bisects AC. It's an angle bisector because it split B into 30 and 30. And I guess technically it's a median because it goes from the vertex to the midpoint on the opposite side. So this is a super special segment. If you don't remember any of the words I just said, that was chapter 5 at the beginning of this semester. You will need to know those eventually. If you forgot them for today, that's okay. But like, you should not know what median means or what altitude means later on. So AC is 2. I just told you that D is the midpoint. So that makes DC half of 2, which is just 1. So DC is 1. BC is 2, and we actually don't know what BD is. So we actually need to find that out. Good thing we learned Pythagorean theorem yesterday because we're just going to do Pythagorean theorem. 1 squared plus x squared equals 2 squared. 1 squared is 1, x squared, and then 2 squared is 4. Minus 1 from both sides. That becomes x squared equals 3. And then square root both sides. X equals radical 3. Hint, there's a lot of radicals in this section. So we just spent the whole front page on radical 2. Now I'm going to join radical 3 in here. If we're looking at the orange triangle that I highlighted BCD, I've got 3 different sides. I've got the hypotenuse, which I think is the easiest word for us to recognize. We've done that before. It's the side across from the 90-degree angle, so it's 2. Now I have short leg and long leg. Short leg is the side that's across from the shortest angle. So if the shortest angle is 30, the shortest leg is 1. The long leg is always the side across from the bigger angle, which is 60, and that's your root 3. If you need to, I would even write like 60 next to long leg and 30 next to short leg and even 90 next to hypotenuse, so you knew which angle went with which. Now that's in this special triangle where one of the side lengths is 2, but not all 30, 60, 90 triangles are going to have length 2. Sometimes they'll have lengths other numbers. So to generalize, we take these values that we just found from our very special, like kind of small scale 30, 60, 90 triangle, and we can multiply them by x to figure out what the long leg of a new one would be. So I would have like x root 3. For the short leg, you could do 1 times x, but that's just x. And then the hypotenuse would be 2x. So what we just did here is a preview to the generalization that we're going to put down here. In any 30, 60, 90 triangle, we can have an extended ratio of this. The short leg is x, the long leg is x root 3, and then the hypotenuse is 2x. We've got the long leg is going to be root 3 times the short leg. And then the hypotenuse is 2 times the short leg. Again, I'm trying to show you as many things. So if you hate the extended ratio, then you need to know those 2 things. If you hate everything I've talked about so far, let's put it on a picture and see if that helps us connect the dots. My short leg is 30, so across from 30, so that's x. My long leg is across from 60, so that's x root 3. And my hypotenuse is the 90 across from 90, so that's 2x. Now a hint, always find the short side first. Always find the short leg first and then find your other legs based on that, because all of them have an x in them, which means the short leg. So everything's in terms of the short leg. Let's talk about if we were to start at the short leg and get to one of the bigger sides. So if I was to start at the short leg and go to the longer leg, I'm going to multiply. So anytime you're getting bigger, we multiply. And this time we're multiplying by root 3. From the short leg to the long leg, multiply by root 3. Same thing if I'm going from the short leg to the hypotenuse, I'm still getting bigger. I'm going to multiply by 2, just a normal 2. Not root 2, normal 2. Okay, simple enough. The reverse is just we're not multiplying, we're going to divide. So if I have the hypotenuse and I want to go to the short leg, I'm going to divide by 2. If I'm going from the long leg to the short leg, I'm going to divide by root 3. Anybody have any questions so far? For all ratios, all kind of what am I multiplying or dividing by? All right, I've got 5 examples I want to go over before class is over. Any questions on what I've done so far? Okay. A little statement I've got right here. It says, remember the shortest side of a triangle is opposite the smallest angle. So the shorter leg in 30, 60, 90 is always opposite the 30 degree. Long leg is across from the 60. I said that, but I didn't write it. So it is written right here. So don't be afraid to like reread your notes when you study. Who would have thought, right? What a novel concept. All right. So this first example, there's 5 little boxes in a row. So we're just going to go one at a time. It looks like it gave me the side across from 30 first. So it gave me the short leg. 2 root 3 is a short leg. I don't care what number, what nonsense I give you. We're still always multiplying or dividing by 2 to get the hypotenuse, multiplying or dividing by root 3 to get the long leg. That's all it is. Don't make it harder than it has to be. Since I have the short leg, I need to grow. I need to get bigger in both of these. So to go to the long leg, I'm going to multiply by root 3. To go to the hypotenuse, I'm going to multiply by 2. And I'll do one of these one at a time. So long leg. I have to do my short leg, which is 2 root 3, and I need to multiply that by root 3. 2 root 3 times root 3 is like 2 times 3, and then 2 times 3 is 6, so y, or my long leg, is equal to 6. Now I'm going to take my short leg and go to the hypotenuse. Everything comes from the short leg. Short leg times 2 gives me my hypotenuse. So my hypotenuse comes from 2 root 3, ooh, that's a funky 3, times 2. Just like we only multiplied the radicals together, now I can only multiply the non-radicals together. So 2 root 3 times 2 is 4 root 3. So x equals 4 root 3. Any questions? Okay. The next one is the hypotenuse. I gave you the hypotenuse of 12. So again, we always find the short side and then we can go to the long side. So whatever is given to us, if it's not the short leg, go to the short leg first. So to go from the hypotenuse to the short leg, I'm getting smaller. So I'm going to divide by 2. Now the short leg is across from the 30, so that's B. So to go from 12 to B, I'm going to divide by 2. Short leg is 12 divided by 2. And so B is 6. Any questions so far? Okay. Now I'm going from the short leg to the long leg. So if I'm going from short to long, I'm getting bigger. So I'm going to grow. I'm going to multiply by root 3. So long leg is going to be 6 times root 3. Well, that's as simple as that gets. Little a is 6 root 3. Okay, we've done 2 examples so far. I've given you the short leg and we found hypotenuse and long leg. And then I gave you the hypotenuse. So we had to find the short leg first and then we found the long leg. Anybody questions yet? Okay. The third example is kind of like the third type I could give you. I gave you not the short leg, not the hypotenuse. I gave you the long leg this time. I know because if what the angle that's already labeled is 30 and 90, then the last angle has to be 60. And across from 60 is my long leg. So 5 root 3 is my long leg. Again, we always find our short leg first. So I'm going to go from my long leg to my short leg. And we have to go from long to short, which means we get smaller. So I'm going to divide by root 3. So short leg is 5 root 3 divided by root 3. Oh, that's nice. The root 3's cancel out, so my short leg is just 5. Little b equals 5. That's pretty easy. Now that I have my short leg is 5, in order to go from my short leg to my hypotenuse, I have to get bigger, so I'm going to multiply by 2. 5 times 2 is going to be 10, so little a equals 10. I've got 2 more examples, which are just a little bit of different algebra, but like the the three types that I could give you the short leg, give you the hypotenuse, give you the long leg. I've done all of those. Anybody have any questions yet? Just to bring this back into the first page was all root 2. We either multiplied or divided by root 2 on anything. Multiply or divide by root 2, multiply or divide by root 2. On the back page, again, it depends. When you're dealing with the hypotenuse, it's always times or divide by 2. If we're dealing with the long leg, it's times or divide by root 3. So you really only have 3 things we worry about with these types. Is it root 2? Is it root 3? Is it just normal 2? So if you're feeling overwhelmed, try and break it down as simple as possible. Okay, all we're worrying about, and these are 30, 60, 90. So all we have to know is it root 3 or is it 2? It looks like this next one, I gave you the long leg. It's across from 60. So I need to find the short leg and then I can find the hypotenuse. To go from the long to the short, I'm getting smaller. So I'm going to divide. And the short leg is not across from 90, so the short leg is y. So to get to y, I need to divide by root 3. Short leg is root 6 divided by root 3. Now you could rationalize these, but it's actually easier to just divide 6 and 3 and just keep the radical with you. So when you have two radicals being divided by each other, you can just divide them and make sure that the radical stays. 6 divided by 3 is 2. So radical 2 is my answer for y. If you want to rationalize or you don't understand algebraically how that works, just see me outside of class just for sake of time. Now I have my short leg, so we need to go from short leg to hypotenuse, which is bigger. So I'm going to multiply by 2. So hypotenuse is going to be 2 times root 2. Oh, well, that's just 2 root 2. So x is equal to 2 root 2. Okay, we're heading to the last one. Any questions so far? All right. My last one, I gave you the hypotenuse. So the hypotenuse is 8 root 3 over 3. You're probably like, oh, Miss White, can we just be done for today? No, because this is not terrible. The algebra is the hard part, not the geometry. So simplifying this might be the most confusing part, but the geometry part, knowing what you're multiplying or dividing by, is not the hardest part. If I'm going from the hypotenuse to the short leg, I need to get smaller. The short leg is the y because it's not x across from 60. So this angle up here must be 30. So y is the short leg. So in order to get to y, I have to divide by 2. Hypotenuse to short leg, divide by 2. So short leg is going to be 8 root 3 over 3 divided by 2. Remember that divided by 2 is the same thing as times 1/2. I think it's easier to think about it this way because, oh, look, I've got a common factor with 2 and 8. They both have a 2, so I have 4 and I have 1. Reminder, when we're multiplying fractions, you multiply the tops together. So I've got 4 root 3 over, or times 1, so I get 4 root 3. And I've got 3 times 1, so 3 is on the bottom. So y equals 4 root 3 over 3. Now that I have the short leg, I need to go from the short to the long leg. So I have to grow, I have to get bigger. I have to multiply by root 3. So long leg is going to be 4 root 3 over 3 times root 3. You can think of it as times root 3 over 1, if that makes you happy. We can't cancel anything out because I've got a normal 3 on bottom and then root 3 is on top. So those don't cross each other out. But root 3 times root 3 is a normal 3. And then 3 times 1 is 3. And you can multiply 4 and 3 and get 12 and then divide that by 3. But I think it's even easier to see, oh, I've got a 3 on top and a 3 on bottom. That makes my long leg just be 4. So x equals 4. Okay. All right. I am finished with notes. I want to go over homework and do one more quick thing before I dismiss you. But does anyone have any questions before I walk away from the notes? The math is not hard here, but you need to be very aware and know what you're doing, either multiplying or dividing, and by what number you're doing to get to each part. You may not need to show this much work. I'm showing this much work because I need to explain to you each step. As you get better at these, you may not need this much work, but if you've just got random numbers down, that may not show enough to me, or you might not have any idea what's happening. And these are not random numbers. They come from my ratios, root 3 and 2 and root 2. So there's a reason, there's a purpose, there's an intention behind all the numbers that we're using. Your homework practices this, and we'll go over your homework at the beginning of class on Thursday. So I think I see you guys tomorrow at the very end of the day. We're going to learn a new lesson. And then next week when we're back in person, where we're going to review all this before we take a quiz. You are quizzing on 8.1, 8.2, and 8.3, and all of those lessons I've taught you online. I know that that's not ideal, but you need to decide what you know and what you don't know before we come back to school next week on Wednesday, because we'll do like a review day and then we're going to quiz. It's going to be very quick and you can't wait last minute to study this stuff. Let me go out to Schoology very quickly to remind you what your homework is. So your homework is called this, homework 8.2, 8.1, day 2. If you see, I gave you a little triangle at the top of your homework paper. So if you didn't even have your notes, or if you didn't take good notes, I've got this little key up here. The biggest thing though is these special right triangles are kind of moving around. I start with a 45-degree triangle, which is the front page of your notes. But then I go to a 30-degree triangle, which is the back page of your notes. And then number 3 goes back to a 45. So we're kind of flipping back and forth through our notes. So really be aware of which triangle you're trying to solve. Is it 45, 45, 90? Or is it 30, 60, 90? Be very aware. Back page is Pythagorean theorem. Pretty self-explanatory. I don't have a little submission box, but I'll put one up later today. But I am done.